It's very technical jargon. Fine, good. Restart.
Yeah.
Okay. Hi everyone. Welcome to another session of Ascent. And today I'll be. I have. I have. I've written this term, Physico-Vedantist. So I will try to explain what this term is, and this is completely made up by me. Okay, it's a term made up by me, and it is all my interpretation. It's all open to discussion. We can change everything, including the title as well. Uh, okay, so what I'll be talking in this talk is so I will take an example, and so it's going to be a life cycle of a person. And through this life cycle, I will explain the stages of becoming a physico-Vedantist. So that is what I'll be discussing today. So we'll start off with a kid. So every one of us has been a kid before. We have gone to school, we have done some experiments in school, we have tried to read books, although most of us what we do is just mug up and write our exams and forget about it later. But this kid is special. This kid is not just a simple kid like us. He doesn't just attend exams for the sake of exams. He doesn't study science for the sake of science. This kid is a curious kid. So, what does it mean to be a curious kid? So, uh, so what happens is in school, whenever we are introduced to a topic, uh, we are introduced to that topic at a very basic level. For example, so I'm taking an example here. I'm taking the example of magnetism. So I had introduced this example thinking that we'll continue the session from last time, where the kids had stopped and the kids had done this nice, beautiful magnetism experiments. So what they learned in that is, with a basic magnet, you can kind of align the magnets with the poles in such a way that you can either pull the magnet with another one or you can push the magnet. So, so this kind of an understanding is what technical is what kind of goes into a student's knowledge book. This kind of examples, things you see around us at a very functional level. So most of us, what we do is we study this. Maybe they'll introduce some one or two basic formula that we call, and we study it, and then we just kind of drop it there. But uh, a curious kid, what he does is he takes this example and he thinks more about it. So he says, okay, I can do push and pull with magnets. So can we do something more? Can we apply this in real life situations? Can we try to bring this concept? Can we manipulate this concept of magnetism and try to do something more practical with it? This is what a curious kid thinks. Now, this curious kid now grows up and now he's become an engineer. So, uh, basically, in the life of an engineer, what we try to do is we try to see if things can be done, if things can be made, if things can be applied. So, you take a concept, for example, like magnetism, you observe some things, like it can pull in some directions and it can push, it can pull in some way and it can push in some way. So now you take this full concept and you try to apply it. So that's the life of an engineer. So now this kid has grown up. He's continued that passion in life. He's not a kid anymore. He was a curious kid. He became an engineer. So this is engineer happening out of passion, okay, not like Indians who become an engineer first before they become anything else, right? So this engineer is born out of passion and he wants to pursue and he wants to make something out, right? So then a lot of these engineers come up, and essentially the same principle of the magnet is now being used to make trains, a real life application. So this is what we call as a maglev train. And the way it works is essentially through magnets. So it levitates due to the repulsion. So you align the poles and it repels. And the way it propels forward is through these opposite poles attracting. Right. So simple technique like pushing when the poles are the same and pulling when the poles are different is being used in a very grand scale here, making a real life application, making a train. So this is the engineering aspect of things, right? Now what? Now this engineer, this kid who initially had a lot of curiosity when trying to understand a simple concept like magnetism, has tried to apply it in a real life scenario and has made something out of it. So that means the kid has actually understood something very fundamental about how things work. But this is just this is just again trying to apply some principle that you have understood that you have understood, right? But why exactly did this come from? Can we have other kind of ways in which we can mimic this magnetism itself? So trying to understand the root cause. So why does magnetism exist? Why does this pushing and pulling of the magnets themselves exist? Is what at this stage, if the curiosity holds for this engineer, comes up. So we now have a kid who has studied something simple. He's grown up, he's carried out, he has had passion, and he's carried out this technique, and he has used this principle in a situation. Now comes how to understand this principle itself. So this is what happens when an engineer becomes even more curious, and that's how you turn into a physicist. So essentially now you are no longer you no longer want to have a physical application for things. What you're more interested in is why something came, so that it could be a potential application later. So this is what a physicist does. So trying to understand the why so that you can make a how. So this is the next stage. So there's a kid becomes curious, tries to understand engineering aspects, becomes more curious, and becomes a physicist. So now what a physicist does is studies things at a very, very, very fundamental level. So he builds these kind of big accelerators, for example, to study how magnetism fundamentally comes up, and he finds out that there are these fundamental forces in nature. One of them called as the electromagnetic force, and because of this electromagnetic force, magnetism comes up, and so on and so forth. And he tries to study things at an extremely fundamental level. So this is one of the main questions that drives a physicist. What is the fundamental nature of the universe? So somewhere along this journey of the physicist, if the person holds enough curiosity, and if the person has understood enough by applying and understanding concepts extremely deeply, uh, he comes to a physicist often comes to certain realizations. So the first thing a physicist usually comes to know is, because we study things at a very deep fundamental level, we find out that things are actually changing at a much rapid pace, at a at that very deep fundamental level. So uh, so physicists can understand, so for example, how an atom moves, how electrons come up, like, so they're like short bursts. They come, they die, they come, they die, they come, they die. It's sort of like a heart beating. So that's how all of these particles are, like, they dance around, they come up, they go, they come up, they go. So all of these, so a physicist is able to understand these kind of changes that happens in nature, at a very deep level, and we kind of understand how ephemeral or how fleeting, the nature of this universe is. It all pops up 1 second and then it all dies down in the next second. And this is how nature behaves, and this is the fundamental understanding that a physicist gains when he looks very deeply into the real nature of this universe. So once a kid who has gained enough curiosity tries to apply that concept, becomes more curious, wants to know things deeply, and then comes to this realization that things are essentially uh, this that things are essentially changes. All the things that we see around at a very deep level are changes. Once he comes to this realization, and if he's fortunate that he meets a guru, then some of these sentences that are made in Vedanta, like many of these concepts essentially, like Sarvam Maya, Brahmam Satya Jagat Mithya, Brahma Satya Jagat Mithya. These concepts kind of resonate well because we understand change deeply. This one sentence of everything is Maya. We are able to connect this sentence. We are able to connect to this sentence because everything is Maya is essentially kind of like saying everything is just change and everything just changes. And because we understand change at a very deep level, we understand that yes, everything, including the tiniest of the tiniest particles and the largest of the largest particles of this universe, changes. And we also kind of understand that everything is changing, but still there must be something in the background that is not changing because simply because these changes are observed. So we kind of relate to this other sentence, Brahman Satya Jagamiti, although we don't understand what Brahman is, but yes. Uh, but the point that I'm trying to make is that we are able to relate well with these concepts of Vedanta. So this is when finally this scientist over here, or the physicist, essentially understands these concepts of Vedanta, studies them under a realized master, and then becomes this guy called the Physico-Vedantist. So this is the final stage of that person, Physico-Vedantist. Uh, and this is the concept that I wanted to introduce by taking this life journey. And if this final slide, I just wanted to show you this, I just wanted to summarize this life cycle. So you start off with a kid. Now he's just not an ordinary kid, he's a curious kid. Once you have a curious kid, there is so much curiosity and passion in that kid. He becomes a very passionate engineer. He wants to apply these things. He's not a normal engineer. He's not one of the kinds who does engineering first and does everything else later. He's a passionate engineer. He's come because he was a curious kid. And once you become a passionate engineer, you develop more curiosity and passion. And then you become the scientist. And it's you simply don't stop here. Once you become a scientist, you need to become a humble scientist in order to move further. Because only when you're a humble scientist can you develop an extremely deep sense of curiosity and passion, and that is when you meet a realized master, and you learn the concepts. You learn Vedanta from a realized master, and you turn into a Physico-Vedantist. So this is the life cycle.
Very
All right.
wonderful. Wonderful. Now, can you remove this thing? I have questions. So I thought a scientist as a junior scientist, senior scientist, Nobel laureate and all, that's the career map. You have put a career map as a Vedantist.
Yes. This is the career map for a Vedantist.
Now, after a senior scientist and then he'll become a guru or he'll become Vedanti. That's the next step in the career map.
No, that's it. Once he becomes a Physico-Vedantist, that is the end, because science and Vedanta is merged.
So there is actually Vedanta, the science and Vedanta. In between, there is something called see, you come from a experimental physics, right?
Yes.
So there's a experimental jnana that's called yoga. So basically, it actually observes the internals of the body-mind complex, consciousness and effects of the internal body-mind complex. Like you observe in a equipment, the yogi, typically a kriya yogi, the kriya yoga, you're able to observe the consciousness and effect of consciousness within the body, nervous system and the body, in the brain.
Okay.
So basically, they speak in terms of Vedanta speaks of Maya and this language of Mithya and all. The Kriya Yogi speaks in terms of electricity, magnetism, and basic forces of nature observed within the body-mind complex and subatomic particles. So basically, the body becomes the laboratory. So the Vedantin inquires with the reasoning and understanding, whereas Kriya Yogi does the what you call as experimentation with the body-mind complex. So basically, spinal cord, they generate what they call as electricity and magnetism. And within the brain cavity, they are able to see the functioning of the cosmos. This is where our rishis found the principles of operation of the this thing. They not only found Maya nature of the world, they also found the functioning of the universe. Okay, they found the laws of the universe, deeper laws of the universe. The deeper laws of the universe don't come from Vedanta, they come from the yoga. Okay, so whatever you said, it was wonderful. I'm very happy to see you are becoming more and more Vedantin, less of Physico. You started as a Physico, a curious kid, an engineer, probably a scientist. Now already you are in the face of Vedantin. Very nice. So right, there is like actually in science, there's a theoretical physics and practical physics, right? What I'm saying is experimental physics and theoretical physics.
Yes.
Which category of physical you are?
It's both. So experimental and theoretical, because the experimental theory aspect is just saying like, okay, there's a concept, but but experimentally you have to like do the experiment, right? So
Right.
at any stage, I guess if you look at science in general, at any stage there's always going to be a theory aspect, there's going to be an experimental aspect to it. One must be efficient in both in order to succeed. Like, for example, a curious kid. The problem with the curious kid is the kid is never experimental in life. In school, all we do is learn formula, mug up, and then write an exam. we'd never play around with magnets, go to school, play around with magnets and see how exactly this push-pull works, right? But as soon as we do something, that concept sticks in our head even more.
Correct.
So at any stage, like in all of these stages, there's always a theory aspect and there's an experimental aspect. Without
Correct.
both, you kind of can't succeed.
So basically, you are a hybrid of theory and experimental. That's what you're saying.
So like everybody is kind of an hybrid of a theory and experiment. It's just what percentage you are. It's just that once you come to these stages of doing physics, a person can't do everything in life because there's too much to know, too much to understand. So you pick something and then you try to understand some small concept.
Okay. So in
So
Vedanta,
yes.
when Vedanta equivalent theory and theoretical and practical is equal to Vedanta and Kriya Yoga for me.
Okay.
I'm saying equal to
I
analogy.
see.
Okay.
I see.
Research and experimentation both go together
Okay.
in Kriya Yoga and Vedanta. So Vedanta is more of a equivalent of theoretical. It's practical also. I'm not saying it's no, but it's actually getting out of Maya, whereas Kriya Yoga is observing within the Maya.
Okay.
Right. So you may find some of the literatures of Kriya Yoga very interesting, where you see the terminologies of what I'm saying, so a practical, what I call experimental scientist.
I see.
In Vedanta, is like going out of the domain of observation. Yeah, right.
Yes.
You're actually getting out of the Maya. So
Yes.
Kriya Yoga is within the domain of Maya, observation.
I see. I see.
Okay. So good to hear, Pranav. So now you're a theoretical and experimental scientist and Vedantin. Very good. So sometime I'll discuss Kriya Yoga with you.
Yes. We can
I will
discuss
give you
Kriya
exposure
Yoga.
to what you call as Maya to you. Now within the Maya, how the universe functions, we'll find out.
Yes.
Very nice, wonderful. Anybody has a question, Shravan?
No, actually, that's
your physics colleagues agree with this, or they fight with this?
I didn't hear that. Can you repeat it?
I'm saying you are speaking of Physico-Vedantist.
Yes.
So other people, what your scientific community, are they for or against this concept? Wow, why are you mixing up religion and philosophy into science? You are making polluting science.
If you look at the history, there are many physicists essentially who have been influenced by, or who have found out, or who have at least found out that Eastern philosophy especially is very, very fascinating. So we have had scientists from like 1900s, like Einstein, Schrodinger, Heisenberg. Even now, like if you look at Indian scientists, there's been like very recently, like George Sudarshan, and all of these people who are like at least really very heavily influenced and ready to open up and talk about things in Vedanta. So it's not so that's why I feel like it's like they can connect to it in some form or the other. Uh, uh, some concept. So uh, yeah, so it's not totally thrown out.
So basically,
In fact, I remember one thing. So I had so last time when I came home, I had gone to IIT Madras, and I actually had philosophy discussions with two of my professors.
okay.
And then after the discussion, one of the professor is like, I like Indian scientists are different because Indian scientists have to deal not only it's harder to become an Indian scientist also because being an Indian scientist, you have to deal not only with concepts of physics, but you are also introduced these concepts of Vedanta, and you have to deal with these concepts also. So, so trying to make connections, trying to see if like people are introduced to Vedanta, and yeah, it was a very nice discussion that I had. So yeah, so essentially at some point, like many people are actually introduced to Vedanta in some form or the other. Many people just drop Vedanta at some point in life because they think it's not useful or not fascinating enough. But I'm pretty sure physicists at least take it up at some point in their life because it is fascinating, and we do find all of these connections.
The Vedanta will be meaningful, fruitful when you discover innermost peace, scope. Otherwise, it will be just a sort of a intellectual exercise. So until it is actually Vedanta is not about philosophy, it's about darshana. So there is a lot of confusion in scientific community, and anyway, is basically religion is confused with the spirituality. And spirituality is confused with the philosophy. Vedanta is not a philosophy system. The philosophy is more of a love for knowledge. Okay, Vedanta is nothing to do with philosophy. In fact, Vedanta is about darshana. Darshana means to see is to be, to realize the truth in its essence. So that's where I think people get confused or lose interest. Confusion of spirituality with science, spirituality with the religion, and religion, spirituality with the philosophy. So there is an intense debate goes on. Dvaita Vedanta, Advaita Vedanta, Vishishtadvaita, which is right or wrong. So there's a philosophical discussion. Okay. But in reality, either Dvaita Vedanta or Vishishtadvaita, Advaita Vedanta is not a philosophy. It's a darshana, means realization. So the gap between understanding and realization is the big difference. So the people who are after philosophy, they lose interest after some time because it becomes more of a mind game. Vedanta is not a mind game. Vedanta is going beyond the mind to realize the truth in its essence. Like a scientist goes into the depth of the, it doesn't get satisfied with the theory or equation. He has to find out the essence. The Vedanta is to find the essence of the existence. Until you hit that, it becomes more of a sort of a conceptualization
exercise.
Intellectual exercise. Interestingly, you have done your PhD, right? So
yes.
The PhD
almost about to.
Philosophy, a doctor of philosophy.
Yes.
You have a doctrine.
Yes.
A philosopher has a doctrine.
Yes.
That's why he's doctor of philosophy, right?
Right.
And doctrine comes from the mind. The Vedanta comes from beyond the mind. So the philosophy is a stepping stone for the Vedanta. That's why you have said Physico-Vedantist is the right way. But once you step, the lower step will go. Okay. Okay, thanks, Pranav.
Yes. Guruji, there is a question in the chat.
There's a question in the chat. What is the question?
Gayatri, I think, asked a question.
The questions are two. The first question, Pranav, is a pure theoretical physics possible? That is a question from Gayatri ji.
What is pure theoretical physics?
I'm saying we discussed theoretical physics and experimental physics. So you said both is a combination. Is there something called theoretical physics only?
I mean, what is theory and what is experiment is kind of like mixed up over here, right? Because, I mean, you can think of theory as, so theory is an intellectual exercise. So you can think of it as, so there are these words called thought experiment. So
Pranav, your video is for. Go ahead. Now it's okay.
yeah, okay. So there is this thing that we use often called as a thought experiment. So what is a thought experiment? A thought experiment is essentially conceptualizing something and conjuring up something in our head. So it's like, so let's say the idea of how a phone works has never been implemented.
Correct.
But you can conceptualize, you can think of a device in the future. Say, in the future, there can be something with which I can communicate using radio waves, an object, right? So another thing would be like going at the speed of light. So
Right.
there has been nothing. Today. There is no experimental. There is no physical object that can travel at the speed of light today, but you can think of and conceptualize some things in some way so that you can propel yourself at speed of light. So this is a thought experiment. So this is called as a thought experiment. So this still comes in the, so as of now, all thought experiments still come in the realm of theoretical physics. What we do is, what experimental physicists do is essentially come up with the physical world realization of it. So that is what experimental physics. That's why, like at any stage in science, you need both. Because if you don't have an understanding of how a concept works, you can't build it. At the same time, if you don't have a reasonable understanding of how things are built, then you can easily come up with situations that are like impossible in life. Like, for example, I don't want to say this, but there's something called a string theory. So they use 10 physical dimensions there. So right now we just have 3 physical dimensions, and you're made up 10 physical dimensions. So like there's no way to test anything in these theories. It exists. It tries to explain a lot of things, which is why it's still there. But it's just there as a theory. So that is an extreme case of where, as of now, there is no probable experimental way of understanding how the theory works. So yeah.
So basically, what you're saying is a theoretical physics is nothing but thought experiments.
Yes, theoretical physics is nothing but thought experiments.
Experimental physics is nothing but physical experiments.
Yes, that's right.
Right. So if thought experiment cannot be, there is no technology today to try the thought experiment. For example, string theory, there's no thought experiments cannot be tested because there's no technology today.
Yes.
One day the technology may be there where thought experiment can be tested with a physical experiment.
Yes.
Right. String theory, probably one day you'll have some instruments to test the string theory.
Yeah.
Then
one day
then it becomes experimental physics.
Yeah, no. So so experimental physics is essentially the way of it's essentially the way of making the technology. So the way you probe things, it's essentially making more innovative ways of trying to understand how things work in the physical, in using a physical instrument, essentially.
Physical instrument. Wonderful.
Yes.
So next question from Gayatri ji is Jagat is Mithya in Vedanta.
Yes.
So for physics point of view, because atomic particles are appearing and disappearing every moment, take birth and keep moving away. So physics point of view, Jagat is Mithya because of atomic particles.
Oh, okay. Okay, not yet.
Do you agree with Jagat Mithya because of subatomic particles?
No. So that's why, like, I always like to think, and I always bring it up in many of my sessions, never to equate concepts of science, concepts of physics with concepts of Vedanta. you can draw similarities, you can draw conclusions, you can draw similarities, and you can use that as a stepping stone to try to understand concepts of Vedanta.
Okay.
But never to equate these two. So the fact that particles come out and die, can it be said that the universe is illusory? Okay, there are big questions here. For a scientist will have problem with this, because he will ask what is death, what is birth of a particle. He'll ask what is illusion, and you'll have to go and define each of these concepts, and then you can equate things. So if you say illusion is equivalent of saying change, then a scientist will agree to
Okay.
this statement. So that is the way I like to think of things. At some point in life, you'll have to give up these concepts. So these concepts are just essentially stepping stones to understand and come to some larger conclusion in life. So uh, so uh, rather than trying to get involved in the nitty-gritties and intricacies of whether this statement is actually equal to this, I would say it is more like trying to come. So when somebody says like Jagat Mithya, I need a way of, the first thing that for me at least, the first thing when I try to understand this concept is I try to relate to something. So it can be anything, right? It can be something very simple. So it can be something very simple as cooking, for example. How do you realize Jagat Mithya in cooking? So you are making sambar. So you add vegetables, you add tomatoes, you add tamarind and everything. Each of them have their own unique, distinct taste. But you put it in a you put it in a pot, boil it, and mix it, and everything seems to be very different. You don't taste the same. You don't taste in them individually anymore, right? You taste them as a group. Now, how did that come up? Like, so many things have changed there, right? So like, things don't seem to be composed of their individual elements anymore. You can't break it down anymore. So, and things are changing all the time. So like, you use this concept now. That you're cooking one day, you're making somewhere, and you realize this. So it's that point of like coming in terms with realization, rather than uh, trying to hardcore set one concept with another and trying to equate these two. So that's the point.
So
So
basically,
for me, at least, trying to come to this realization through cooking is harder than when I was studied so much physics. So that's why I'm saying it's easier for a physicist to understand these things.
basically, don't get stuck with the concepts.
Yeah.
Finally, what insight you develop from the concepts is makes a difference,
Yes, that's exactly what I wanted to say.
right? So,
Yes.
is there a difference between insight and intuition?
What is intuition, Guruji?
We'll go into
Insight is based on understanding.
Okay.
Logically, you come to understand some deeper aspect of reality. That's called intuition, intellect, insight. Right? For example, you observe the stock market. Then finally, you come to, based on the behavior, you come to understand this how it will behave. It's more of a data-based understanding.
Okay.
Whereas intuition is a holistic understanding.
Okay.
So scientist works on intuition or insight.
He needs both.
So Vedanta is finally intuition.
Many scientists work with insight. Great scientists work with intuition.
Okay. So Physico-Vedantist means insight and intuition working in harmony. Okay. So did your question get answered? Do you have any follow-up question on that? Jagat Mithya?
I think Gayatri was asking that question.
Yeah. Gayatri, do you have a follow-up question on that? Yeah.
No, Guruji. Guruji, what is the difference between illusion, delusion, and hallucination?
So, illusion, delusion, and hallucination. What is the difference?
And out of this, which one is mithya part? Which word applies to mithya?
So, do we take up as a science this discussion, or
No,
we take
because
it?
see, just because all these particles are changing or whatever is happening at that, I don't know the exact terms. So just because of that, we call it as mithya. I mean, so the nature of the particles is mithya, or because the particles are like that, the nature of the universe is mithya.
Now, Gayatri ji is going beyond one step beyond the physics and Vedanta. She is going much deeper. So, illusion is there is a reality which appears as something else. A
There is
rope
a reality.
appears.
So there is a reality. We are acknowledging that there is some reality.
Yeah, there's some reality. It appears as something is called illusion. Okay. Hallucination is there's no reality. It appears as something else. There's no reality at all. It appears as something else.
It just appears.
Huh?
It just appears.
Yeah, it appears.
Hallucination.
So
Without
there's no
any
question of
reality.
reality. Just appears. For example, I see a ghost here. Okay. That's a hallucination. So delusion is the confusion in the intellect which creates wrong understanding about life, about anything.
So the
Shravana,
dream, our dream in the sleeping state is that illusion, it's hallucination, right? Then
it is actually illusion because there's a background sleeper is always there.
in hallucination also, I am always there. Without me, the hallucination doesn't happen at all. I am there now to